So we're going to talk about solving rational equations in this video. Just the first thing I want to mention is kind of how do we solve equations? We essentially do the same thing to both sides to try to simplify. And when you have rational equations, essentially that means you have fractions. So for example, right here, you have the fraction 4x over x minus 1. That's a rational function. So you want to clear fractions to simplify. The most direct, there's more than one way to clear fractions, but usually the most direct and straightforward way is to find the least common denominator and then multiply both sides of the equation by that. And if you find the least common denominator and you multiply both sides of the equation by that, then you'll clear all the fractions all at once. And if you just multiply both sides by one denominator, then you'll start to clear fractions one at a time, but it won't be as simple. So usually for rational equations, that's our goal. It's not the only way to do it, but it's the most straightforward and kind of simple. So let's do that with our first example. So we have 4x over x minus 1 is equal to 6. I only have one denominator here, so I'm going to multiply both sides by x minus 1. So if I have 4x over x minus 1 is equal to 6, I multiply both sides by x minus 1 to clear that denominator. Then on the left side, x minus 1 divided by x minus 1 cancels. I'm left with 4x. On the right side, I get 6 times x minus 1, and I have to remember I'm multiplying the whole side by x minus 1, so I'll have to distribute if need be. So I might need to distribute. Then I could potentially subtract 2x from both sides and get, sorry, not 2x. I'd subtract 6x from both sides, get negative 2x is equal to negative 6 on one side, and then divide both sides by negative 2, and I get x equals 3. I can check this answer just by plugging in my value and making sure it's a solution. So I'll plug in x equals 3 to check. If I plug in x equals 3 into the left side of the equation, I get 12 over 2 or 6. And that's equal to the right side of the equation, because 6 equals 6, right? So this is kind of your straightforward first example where you just have one denominator to clear, so I'll multiply both sides of the equation by that denominator. But with more complicated examples, you might have more than one denominator. And like we mentioned, we were going to find the LCD. So the least common denominator here, I have x plus 2, I have x, and I have 5x. So my least common denominator is 5 times x plus 2. And I can multiply both sides of this equation by that, and it will clear all of my fractions all at once, and I won't have to do any more to clear my fractions. So let's look at what that would look like if I'm going to multiply both sides of my equation by 5x times x, 5x times x plus 2. When I do this on the left, I have to remember I'm multiplying the whole equation by 5x times x plus 2, not just a single term. in the equation, and then I'll distribute as I go. So if I distribute for my first term, notice that my x plus 2's cancel. So I have 5x times 3, and my x plus 2 over x plus 2 has canceled. For my second term, my x's will cancel. And then on the right side, my 5x's will cancel. So you can see that that simplified this equation dramatically. I just have 15x for my first term. I just have 5 times x plus 2 for my second term, and I just have x plus 2 on the right. And so you can see how using the LCD has cleared the fractions, essentially. That's how we talk about it. Cleared the fractions on my equation, and now I can just solve the equation like I'm used to, and I don't have such complex terms going on. So I can distribute my 5. 15x minus 5x is 10x minus 10. If I subtract x from both sides, I get 9x minus 10 equals 2. If I add 10 to both sides, I get 9x equals 12. And then if I divide both sides by 9, I get x is 12 over 9. I can simplify that to x is 4/3. So again, my steps were to add 10, add 10. Here I was subtracting x, and then dividing by 9. So let's check this answer. So we have x equals 4/3. We're going to plug that in to our equation. We'll plug it in to the left side and see what happens. And then we'll look at the right side. So 3 over 4/3 plus 2, I'm going to have to find a common denominator. That's 4/3 plus 6/3. Remember, when you divide by a fraction, you multiply by the reciprocal. So 1 divided by 4 over 3 is 1 times 3/4. Now for my first term, I get 3 divided by 10/3 minus 3/4. Again, dividing by the fraction means I'm going to multiply by the reciprocal. So that 3 divided by 10/3 becomes 3 times 3/10, or 9/10, and I'm still going to subtract 3/4. I have to do a common denominator here as well. Let's see, my least common denominator would be 20. So 18 over 20 minus 15 over 20 is 3 over 20. So that's the left side of my equation. Now let's look back at the top. The right side was 1 over 5x. So now we're going to check the right side and see if 1 over 5x is the same. So this is 1 over 20/3. Divide by a fraction, I multiply by the reciprocal. It is indeed the same. So x equals 4/3 is a solution to this equation. And we found that by multiplying both sides of this equation by the least common denominator and simplifying. Now let's look at another example. So sometimes you can't tell what the least common denominator is until you factor something. So if you can factor, so if x squared, if this quadratic was irreducible, then I would just multiply x minus 6, x minus 2, and this quadratic together to get my common denominator. But if I factor this right side, then maybe I'll have a least common denominator that's smaller. And I can factor 12 into 6 and 2, and then minus 6 and minus 2 will actually add to negative 8. So it turns out, hidden in this, my LCD was just x minus 6 times x minus 2. And I don't need any more than that. Which is good news because we want to avoid higher powers of x if we can help it. We know how to solve a quadratic equation, but a cubic can give us some trouble. So what I would do is I'd first rewrite this in factored form so I can see what's going on. And now I'm going to multiply both sides of this equation by x minus 6 times x minus 2. And I have to remember to multiply the entirety of each side. Can't just multiply a single term or a piece of it, but I have to multiply the entirety of the side. So when I distribute on the left side, my x minus 6 cancels, and I'm just left with the x minus 2. When I distribute to the second term, my x minus 2's cancel, and I'm just left with x minus 6 times x. And on the right side, my x minus 6 and my x minus 2 cancel, so all I'm left with is 4. And now, once again, my equation has simplified dramatically. So now I can distribute and say I have x minus 2 plus x squared minus 6x is equal to 4. Notice this is a quadratic. If that squared term doesn't go away, then I have a quadratic equation. And the way I always want to work with quadratics, well, I can simplify and combine some like terms. So let's do that first. So I have x squared, I have x minus 6x, so minus 5x. Then I could add 2 to both sides and say that's equal to 6. But I can't solve this using square roots if I have both a bx term and an x squared term. So there's two options I have. I'm going to write this in standard form, which is ax squared plus bx plus c equals 0. And I can then either factor or I can use the quadratic equation. In general, I try to factor it first because it'll be easier if I can factor to finish solving. Quadratic equation is a little bit long and tedious. But if I can't factor it, then I can always use the quadratic equation to solve this. So I'm going to rewrite this in standard form, and I'm going to try to factor. So I need something that multiplies to 6 and adds to 5. And in fact, it multiplies to negative 6, but then it adds to negative 5. So if I have a negative 6 and a positive 1, then that will do it. And this means either x plus 1 is 0 or x minus 6 is 0. Because if they were both non-zero, then they couldn't multiply together to give me 0. X plus 1 is 0. If I subtract 1 from both sides, I get x equals negative 1. X minus 6 is 0. If I add 6 to both sides, I get x equals 6. So I have two solutions to this equation that I started with. the claim is x equals -1 to x equals 6. But I need to check this and see if this works out. So I'm going to check in my 1 over x minus 6 plus x over x minus 2 is equal to 4 over x minus 6 times x minus 2 form of my original equation. So if I plug in x equals -1, then I get 1 over -1 minus 6 plus -1 over -1 minus 2 on the left side. So I get 1 over -7 plus -1 over -3. So -1/7 plus 1/3. My common denominator there is 21. So I get 7 minus 3, or 4, 21 over 21. Meanwhile, on the right side, if I plug in 4 over -1 minus 6, -1 minus 2, I get 4 over -7, -3, which is 4 over 21. Hey, that works. I get the same thing on the right and the left. So x equals -1 is indeed a solution. But now let's check x equals 6 and see what happens. When I plug it into the left side, I get 1 over 6 minus 6 plus 6 over 6 minus 2. But that's 1 over 0. And I cannot divide by 0. Which means this cannot be a solution. So we call this an extraneous solution that isn't actually, it became a solution to the quadratic, but it's not a solution to the rational equation. And so I only have one solution to the rational equation, x equals -1. So just to recap, we started with what looked like a really complicated equation, but we made it really simple, really fast by multiplying by the least common denominator. We wound up with a quadratic that had 2 solutions, but only one of those was a solution to my original rational equation. So here's one more example, and you should try. So you can pause the video and try, and then you can watch the solution that I come up with. So hopefully the first step you did was you found the least common denominator for x, x minus 2, and x plus 2. So that was x times x minus 2, x plus 2 would be your least common denominator. If you didn't get that as a least common denominator, you could pause the video now and try solving this equation with this least common denominator. Okay, once you have the least common denominator, then I'm going to clear fractions by multiplying both sides of the equation by that least common denominator. So x times x minus 2 times x plus 2. And I have to remember on the left side to multiply everything on the left side by x times x minus 2 times x plus 2. If you didn't do that, you can pause the video and go back and see if you can get the same answer. And then I see what happens to the left side of the equation. Well, my x times x minus 2 cancel in my first term, and I'm left with 10x plus 2. My x cancels in my second term, and I'm left with 4 times x minus 2 times x plus 2. And then my x plus 2 cancels on my right side, so I'm just left with 5x times x minus 2. And so this is a lot simpler than what I started with, but I've got a lot of FOILing to do. So I have 10x plus 20 plus, well, let's FOIL this out. First terms I get x squared, inner terms I get minus 2x, outer terms I get plus 2x, my last terms I get minus 4. Meanwhile, if I distribute the 5x and x minus 2, I get 5x squared minus 10x. I'm going to keep simplifying. So I get 4x squared minus, let's see, these terms actually cancel, so I'm not going to distribute there. So I get minus 16, and that's equal to 5x squared minus 10x. And I notice once more I have a quadratic. So I need to remember with a quadratic, I'm going to simplify first. So I have 10x plus 4 plus 4x squared. If I subtract 4x squared from both sides, I'm left with x squared on the right minus 10x. If I add 10x to both sides, I'm left with just x squared on the right. There, I'm showing my work, so it's easier for someone who reads this later to see what happens. And now I realize I have a quadratic, so I can either factor or put in standard form. Well, I put in standard form either way. So I can either factor or I can use the quadratic formula once I get it in standard form. So let's write this in standard form. X squared minus 20x minus 4 is equal to 0. If I try to factor that, I need something that multiplies to 4 but adds to 20. So 4 and 1, 2 and 2, neither of those, no combination, positive and negative, is going to add that to 20. So factoring, I'm going to come up dry on this one. So I'm going to use the quadratic formula instead. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I have 20 plus or minus 20 squared is 400. Negative 4 times negative 4 is positive 16. So I get 20 plus or minus square root of 416 over 2. I can simplify that. I can factor a 16 out of 416. So that'll give me 4 on the outside. So I get 10 plus or minus 2 root 26. And I would check by plugging these into my calculator. And plugging these values and using that for my original equation and make sure that it works. What I do notice is that the answer is not 0 or 2 or negative 2. So I'm not going to wind up with a 0 in the denominator. And so I won't have an extraneous solution. And those are several examples for solving rational equations.